Kia ora tātou, welcome to this video where we will go over the 2019 past exam question 3, cue royalty free YouTube music. So we've got here 3 functional groups. We've got an alcohol group, we have an amine group, and we have a carboxylic acid group. And we need to be able to identify if we had, so if we had 3 solutions, one was an alcohol, one was an amine, and one was a carboxylic acid. How would we know which one is which? How could we use an identification technique to work those out? So the first thing that we know is that amines are, and I'll use blue to show this, they are basic. So that means that an amine will turn red litmus paper blue. So if we, for functional group, we've skipped to B. So functional group B, is NH2. The chemical test that we would use is red litmus paper. And we would observe that turning blue. So the carboxylic acid, so that sort of states in the name, that a carboxylic acid is an acid. So that will turn blue litmus paper red. So we can easily just write that one in. So that is compound C, COOH, blue litmus. And it will turn red. And then the final one is this hydroxyl group, or the alcohol. It's easy to mistake this, because you see the OH there. It's easy to mistake that as a hydroxide group, but it's not, because it's more tightly attached to the carbon. That oxygen and that hydrogen are nicely bonded, and then we've got the carbon bonded there. This does not break away from the rest of the molecule and become hydroxide. So an alcohol is not a base, and it's not an acid either. The hydrogen doesn't break off like that. So alcohols will be neutral, so we need to use a different test, either the bromine water or the acidified dichromate solution, to be able to identify this. So what we would use is the dichromate plus, what's going on there? Cr2O7 2 minus, and what we would observe is dichromate will go from orange to green. If you need any revision on this, just have a look at my video explaining oxidation reactions. So orange, I'm just having to write this twice now, green to green. Describe an alternative method to distinguish between functional groups B and C. Identify the reagent needed, the expected observations, and explain the type of reaction occurring. So B is the amine, so that's the base. C is the carboxylic acid, which is an acid. So we could just use any other identification test apart from litmus paper to be able to distinguish between these two. So one trick that we can use is any carbonate, any metal carbonate. So let's say we've got sodium carbonate. Wait, it's not CO3 2 minus. Don't know how to do ionic formula. There we go. That is a base, because carbonates are a base. And when we have a base plus an acid, specifically a carbonate, we're going to get water, a salt, and carbon dioxide. And this is going to show through as bubbles. So one identification trick that we could use is to use any metal carbonate, and if we observe bubbles, so if we add the sodium carbonate to the base, we won't observe bubbles, so we would be able to say that's the amine. If we add sodium carbonate to the other one and we do observe bubbles, then we know that that is the carboxylic acid. Another test that you could do would be to use magnesium. So we know that when we put magnesium in acid, we get the metal, we get the salt, and we also get hydrogen gas. So it's the production of gas that actually gives us an observable outcome, that we're able to say that magnesium is reacting with the acid. If we put the magnesium in with the base, there'd be no reaction. So that's the first part of it. Next part, so the conversion of bromoethane, let's zoom in a little bit. Bromoethane to chloroethane requires 2 steps, with alcohol as an intermediate product. There we go, so an alcohol is an intermediate. So we know that we're going from bromoethane to CCOH, so we're getting the alcohol as the intermediate. And it doesn't matter where we draw that hydroxyl group, because if we draw it on the other side, if we draw it coming off this carbon, that's still going to have the same name. It's just the same molecule flipped around. So this is ethanol. Bromoethane, we'd have, because it's eth, we've got 2 carbons, BRHH. So how do we go from a haloalkane to an alcohol? You can just look at your reaction schemes to work this out. So we're going to have potassium hydroxide, and it is aqueous. Remember, we can have potassium hydroxide aqueous to substitute a haloalkane to become an alcohol. If that was not aqueous, if that was actually alcoholic potassium hydroxide, then we would have an elimination reaction. So that's just something to differentiate between the 2 states that potassium hydroxide can be in. And then we're wanting to form chloroethane. So 1, 2, we can have Cl, 3, 4. So to go from an alcohol to a haloalkane, we can use PCl3, PCl5, or SOCl2. Any of those and you'd get that correct. So the next question, elaborate on the reaction scheme for this conversion. In your answer you should identify any conditions needed for each step of the conversion. So the conditions is, like when we're talking about potassium hydroxide, that can either be in aqueous conditions or alcoholic conditions. So we're going to need to say in our answer that we require aqueous conditions, the type of reaction occurring for each step of the conversion. So in both of them we're substituting one group for another. So both of them are just substitution reactions. So I think if you just say the conditions that you're required are aqueous, because if we used alcoholic, we would result in an alkene, and that they're both substitution reactions, I think that will get us across the line. Let's have a look at what the marking schedule says. I'll just move the whole thing over. So the 3 structural formulae, ethanol, chloroethane. So we've got potassium hydroxide aqueous is the first reagent. We've got all that right. So both reactions are a substitution, and then the first step requires aqueous to enable the hydroxyl group to be substituted for the bromine. And the second step, there you go. You just need those to substitute the hydroxyl group for the chlorine atom. So it's really just kind of explaining what you've just said. If you explain the substitution reaction, okay, so we need to actually say that the hydroxyl group is going to be replacing the bromine group. So just, explaining that that's a substitution reaction, and then you are there. So the hardest part is just memorizing what reagents you need for that reaction to occur. So thanks for watching. That gets us through the 2019 exam. I hope that's useful for you. We will see you next time.